What if the next step in human evolution doesn't happen on Earth? What if the human body you recognize today is already obsolete for the future that awaits us among the stars? For millions of years, evolution shaped us slowly, bone by bone, gene by gene, mistake by mistake. But now, for the first time in history, humanity is preparing to leave its home planet. And space does not forgive biology. Radiation tears DNA apart. Zero gravity weakens muscles and bones. Alien atmospheres reject human lungs. And the distances between stars stretch far beyond the limits of a human lifespan. So the real question is no longer if humans will change. The question is whether we will still be human when we arrive. Tonight, we are not just talking about space travel. We are talking about the future of the human species itself. Because once we leave Earth, evolution no longer belongs to nature. It belongs to us. In this video, you will discover how interstellar travel could permanently alter the human body and mind, why radiation and low gravity may force biological changes, how genetic engineering could replace natural evolution, what living on alien worlds might do to human identity, and whether the future of humanity leads to survival or something unrecognizable. Welcome to Where the Light Ends, a place where space grows silent, light fades, and the universe begins to reveal its darkest secrets. For nearly all of human history, evolution followed a simple rule: adapt or disappear. Natural selection favored stronger bodies, sharper minds, and traits that increased survival on Earth. But that rule is breaking. Modern humans no longer evolve the way we used to. Medicine keeps the weak alive. Technology replaces physical strength. Culture moves faster than biology. And now, space accelerates this process beyond anything nature ever intended. Earth shaped us for one environment only. One gravity, one atmosphere, one radiation shield provided by a magnetic field and thick air. The moment we leave that protective shell, our biology is exposed, raw, fragile, and outdated. Astronauts already give us a glimpse of what happens when humans leave Earth for extended periods. After months in space, bones lose density, muscles atrophy, vision changes, and even DNA shows signs of damage from cosmic radiation. These effects are not theoretical. They are happening right now. Now imagine interstellar travel. Not months, not years, but generations. Voyages so long that entire human lifetimes pass inside artificial habitats drifting between stars. In that environment, natural evolution becomes irrelevant. There is no nature to select traits, only technology deciding who survives. This is where human evolution splits from its past. Instead of random mutation and slow adaptation, future evolution becomes intentional, designed, engineered, controlled. To survive radiation, humans may need altered DNA repair mechanisms. To function in low gravity, bones and muscles may be redesigned at the genetic level. To endure isolation and vast distances, the human brain itself may be reshaped, emotions muted, fear reduced, attachment reprogrammed. At that point, evolution is no longer blind. It has a direction, and someone is choosing it. But this choice comes with a cost, because the more we modify ourselves to survive space, the further we drift from the humans we once were. The first interstellar humans may look similar to us, but biologically they will already be something else, a transitional species caught between Earth-born humanity and whatever comes next. And this is only the beginning. The moment humans step beyond the solar system, survival becomes a design problem. Every aspect of the human body must be reconsidered, because space does not adapt to us. We must adapt to it. Radiation is the first enemy. Outside Earth's magnetic shield, cosmic rays and solar particles penetrate living tissue, breaking DNA strands and increasing mutation rates. On Earth, radiation exposure is rare and limited. In deep space, it is constant. Over generations, unprotected human DNA would degrade beyond repair. One solution is biological shielding. Future humans may evolve or be engineered with thicker skin, enhanced melanin-like compounds, or even entirely new cellular structures designed to absorb radiation. Another possibility is internal repair systems far more efficient than anything found in nature today, allowing cells to correct damage in real time. But radiation is only one threat. Gravity, or the lack of it, reshapes the human body in disturbing ways. Bones weaken, muscles waste away, blood redistributes, even the heart changes shape. These effects occur within months. Imagine what centuries would do. To survive long-term in low gravity, future humans may become physically taller, with elongated limbs and lighter skeletal structures. Dense bones may become unnecessary. Powerful muscles may be replaced by efficiency. Over time, the human body could become fragile by Earth standards, but perfectly optimized for life in space. And then there is reproduction. Human pregnancy evolved for Earth gravity. In space, embryonic development faces unknown risks. Cells divide differently, fluids behave unpredictably, even brain formation could be altered. This raises a disturbing possibility. Natural human reproduction may no longer be viable beyond Earth. Artificial wombs, genetic screening, and controlled development may become the only way to ensure survival. At that point, humanity is no longer born as it is manufactured. And when birth becomes a technological process, evolution becomes a choice. Traits that once emerged randomly are now selected intentionally. Intelligence may be enhanced, emotional volatility reduced, physical diversity optimized for function rather than beauty. But evolution driven by efficiency carries a hidden danger. What happens to creativity, empathy, curiosity, traits that offer no immediate survival advantage but define what it means to be human? As we reshape our bodies to survive the void, we risk stripping away the very qualities that made us explore the stars in the first place. The future human may survive anywhere, but may feel nothing. And this is where the question deepens. Because biology is only half the story. The mind must evolve too. If the human body must change to survive space, the human mind must change even more. Interstellar travel is not just a physical challenge. It is a psychological one beyond anything evolution prepared us for. The human brain evolved for small groups, short distances, and immediate threats. It is designed for forests, plains, and familiar skies, not endless darkness and decades of isolation. In deep space, time itself becomes an enemy. Months turn into years, years into generations. Entire lives may pass without ever seeing a planet, a sunrise, or an open horizon. For an unmodified human mind, this environment is devastating. Depression, anxiety, paranoia, and cognitive decline are not side effects. They are inevitabilities. To survive, future humans may require neurological adaptation. Emotional regulation may be enhanced, fear responses dampened, attachment patterns altered to reduce loneliness. Memory may be edited to soften the psychological weight of isolation. In other words, the future human mind may be calmer, more stable, and more efficient, but also less emotional. Genetic engineering offers one path forward. By modifying genes linked to stress, aggression, and fear, future humans could be born better suited for confined artificial environments. But this raises a terrifying question. If suffering can be removed, what happens to meaning? Pain, loss, and longing have shaped human art, philosophy, and identity. A mind optimized only for survival may no longer ask questions. It may simply endure. Then there is the fusion of biology and machine. Neural implants could enhance cognition, extend memory, and allow direct communication between minds. Thought itself may become shared, reducing misunderstanding but also erasing individuality. In an interstellar civilization, language may fade. Speech may be replaced by data transfer. Privacy may disappear. The concept of a self may dissolve into a collective consciousness optimized for survival and coordination. At that stage, humanity does not just evolve, it transforms. But adaptation does not end with space itself. Because the ultimate challenge is not surviving the journey, It is surviving the destination. Alien worlds will not welcome us. Their atmospheres, ecosystems, and physical laws may be fundamentally hostile to human biology. Even planets that resemble Earth may carry invisible dangers, toxins, microorganisms, or chemical balances incompatible with human life. To live on alien worlds, humans may need to abandon Earth biology entirely. Lungs redesigned for different gases, skin adapted to new radiation spectra, metabolism altered to process unfamiliar nutrients. Some future humans may become so specialized that returning to Earth becomes impossible. Gravity would crush them. Air would poison them. Earth itself would become alien. And once humanity splits across worlds, evolution splits with it. Different planets will shape different versions of humanity, isolated, diverging, and slowly becoming separate species. At that point, the idea of a single human race ends. There will be many, and they may no longer recognize each other as the same kind of being. When humanity spreads across the stars, evolution will no longer follow a single path. Each world, each environment, each decision will push human biology in different directions. Over centuries, these differences will accumulate until the word human becomes a historical label rather than a biological reality. On high-gravity worlds, humans may become shorter, denser, and incredibly strong. On low-gravity planets, they may grow tall and fragile, with elongated limbs and altered circulatory systems. On radiation-heavy worlds, survival may require bodies that no longer resemble anything born on Earth. These changes will not be cosmetic. They will reshape perception, movement, and even thought. Different environments produce different minds. A human adapted to eternal twilight may perceive time differently. A species born under constant radiation may see danger where others see nothing. Eventually, communication between these branches of humanity may fail. Not because of language, but because of experience. A mind shaped by an alien sky may not understand the fears, values, or emotions of an Earth-born human. This is how post-humanity begins, not with extinction, but with divergence. Some humans may abandon biology entirely. Digital consciousness offers escape from fragile flesh. Minds uploaded into machines would no longer fear radiation, gravity, or time. They could travel indefinitely, copy themselves, and exist wherever energy flows. But a digital mind is not human in the traditional sense. It does not age. It does not forget. It does not die unless deleted. Without death, urgency disappears. Without limits, meaning may erode. Others may choose extreme biological transformation. Hybrid beings, part organic, part synthetic, designed to thrive where no pure human could survive. These entities may view unmodified humans as obsolete ancestors. And somewhere in this future, a moment will arrive when two intelligent beings meet among the stars, and neither recognizes the other as human. At that moment, humanity ends, not in silence, but in multiplication. The species that once looked up at the stars with wonder will become something the stars shaped in return. And the question will no longer be where humans came from, but whether they still remember. Because evolution without memory is not progress. It is erasure. When I think about the future of human evolution, what unsettles me most is not the technology, or the alien worlds, or even the idea of post-human beings. It's the possibility that survival might cost us our ability to wonder. We evolved because we questioned the unknown, because we feared the dark and stepped into it anyway. If we redesign ourselves to feel nothing, to doubt nothing, to endure everything, we may survive the universe but lose the reason we ever wanted to explore it. And maybe the most human act will not be adapting to the stars, but remembering who we were before we touched them. This is where the light ends. Thank you for watching. And remember, some questions are meant to remain unanswered.